So this is a very short talk that I've been meaning to do for some time now. Just now finally getting around to it. I've got three slides that I've been using for a few years now, and based on the feedback that I've got, the conversations that I've had come up, the questions that I've had thrown at me about these slides. I think all said, if there is a signature idea that we have on agilesoc.com, it's probably best captured by these three slides. What they are is a brief overview and a comparison of the waterfall and agile development models. And they really center around this idea of working hardware over comprehensive documentation, which of course comes directly from the Agile Manifesto. So let's start with the waterfall model. Now, just about everything I've ever read about the waterfall model, everything that I've heard includes at least, or what I've heard about agile development includes at least a little bit of complaining about this waterfall development model. And I've always seen waterfall development as something that hardware engineers can relate to. Not necessarily because we do it strictly, but I think it's unknowingly. I think a lot of hardware teams aspire to the waterfall model. So anyway, the waterfall model is a sequential, regimented approach to product development, where you polish off tasks one at a time according to a project plan. There's usually a big Gantt chart created at the beginning of the project and maintained by a project manager. You plan exactly what you need to do for the entire product, and then you go away and do it. Everything in the waterfall model is geared toward this one big bang deliverable at the end of a project, where you design everything, you build everything, you test everything, and you ship everything all in one shot. There are opportunities for lessons learned in the waterfall model, most often called project postmortems, where you take what you learn on project A and then you apply it in future to project B. For me, the waterfall model has come to signify task-driven development, where after this big upfront planning phase, you take your project, you smash it into pieces, you put those pieces in a Gantt chart, you assign people to each of those pieces, and then you track your progress based on which pieces are complete. Now, the Agile model is quite a bit different. First of all, there is no Big Bang release, and instead a product is developed iteratively, and the goal of each iteration is to have some verified, demonstrable, production-ready code that could potentially go to and give value to a customer. So it's not a document, or it's not a lines of code milestone, or some class by class or module by module milestone. It's an actual completed, functioning, potentially shippable part of the end product. Iterations are typically anywhere between 2 and maybe 6 weeks long. Probably 4 weeks is the most common, most commonly used in Scrum. But really, I think the length of the iteration is whatever makes sense to the team and the situation. The shorter time frame is definitely preferred, though, because it's easier for people to comprehend and commit to delivering something in, say, 4 weeks, as opposed to delivering something in 4 months, or 8 months, or 12 months, or even longer. The shorter time frame also provides opportunities to, pardon me, for lessons learned as you go along, and feedback specifically from customers. It gives you the opportunity to add or remove or change requirements and product features as you go along, which incidentally is the kind of feature creep that hardware developers tend to not be overly open to in general. And here you see that type of feature creep actually built into the development model. Also interesting, specifically for hardware people, is the Agile model gives you the opportunity to walk away from with a partially completed product at any time. So you may plan for some massive, earth-shattering, life-changing product to be developed over 2 or 3 years. But then you see, a year or a year and a half in, you have enough of what you need to go to market. So you quit. And potentially that's the type of decision that you could be making, every 4 weeks or so. So that comparison, when I talk people through it, I think people generally understand where we're going in terms of difference between the task-based waterfall model and the deliverables-based agile model. But I don't think it is until we get to this slide where the real fundamental difference sinks in. To me, the fundamental difference is in how you define progress. So if a team following the waterfall model comes to you and says, yeah, we're half done, I think what they're saying is they are half completed, or they're completed half of the tasks that they originally set out to accomplish. Team comes to you following the Agile model, they say they're half done. And what that means is they have coded, tested, documented, and potentially could ship half an end product. So whereas the team following the waterfall model may have absolutely no functionality that could go to a customer, the team following the Agile model specifically has half that functionality ready to go. So these are two very fundamentally different definitions of progress between the two. And like I say, I think for a lot of people this is where the real differences start to sink in. Now, in general, like I said, people are generally open to the comparison. I do get feedback and questions, though, periodically. And one bit of feedback I do regularly get is that people find it unreasonable to think that all these different disciplines or stages in development can line up in the way that I've shown. So a specific example people point out is that it, of course, takes a long time to push a design through the back-end tool chain, or that without some significant amount of documentation done, it's hard to have all of these other phases in development start. So with those in mind, people tend to think a more realistic view of what I have is to have these different stages staggered. People think that looks a lot more practical. Now I will say I don't really buy any of the arguments I've heard against what I show in this graphic. Now the reason I say that, I agree that offsetting each of these steps is more practical, but it's only more practical because it fits with how we generally approach hardware development today. With the tools we use, with the methods we use, the way we organize ourselves, the way we work together, if we can't change any of that, yes, of course, I think that this is very practical, and I think that this is probably the best that we can do. But let's forget about what we do now. The tools we use, the methods we use, the way we organize ourselves and work together, let's forget about all that. Instead, let's take a look at the obvious advantage of constantly being in a state where we could, with say a week or two notice, tape out an ASIC and beat a direct competitor into the marketplace, or on 24 hours notice ship a new FPGA load, or a new version of IP, or limit the amount of time we spend building features that no one uses, or simultaneously releasing hardware and software. I think if all we do is think about what our organizations and development approaches support now, we'll miss out on these advantages and other advantages like them. So when these questions come up, I try and encourage people to not settle for what's practical. I don't think we end up being much better off if all we do is shoot for practical. I think the only way to find massive improvements is to shoot for ideal and see what happens. And that's why I like to call this the idealist view of Agile hardware. To me, this is the only realistic place to start.